up we have Peter. Peter's a PHP developer who's going to be talking to us about Moodle. So he's going to be talking about some of the ways that we can fix some of the issues that we've been talking about today. So hopefully this will be a little bit more upbeat than some of our previous talks today. Take it away, Peter.
Hi, so yeah, I'm Peter. I'm a PHP dev, and for the past 6 months or so, I've been working on Moodle, which is an open source learning management system. So this talk is generally aimed at people that aren't necessarily security aficionados, but more maybe general devs, even end users who want to jump into programming stuff. Maybe looking at the security of the applications you use is a good place to start. So just a little bit about me. I'm mostly back-end. I don't really do much front-end stuff. I work for Catalyst IT Australia, who are actually a sponsor of this conference, and we mostly do open sourcey stuff, so it's really quite relevant. I graduated from QUT, so I'm Brisbane-based, that's where I'm from, and I included my cat. He's very cute. So just some context for this discussion. It's mostly going to be kind of tangential to Moodle. It can be very generalized, the advice. But Moodle, it's an open source learning management system. Maybe some of you have heard of it. It is kind of a niche product, but it's a big open source application. So it's free, it's open source. Its primary use is in the higher education and training space, universities, training colleges, TAFEs. Some governments like to use it for competency and compliance tracking, that kind of thing. It's all written in PHP. It's on 7s, that's good. And its headquarters is actually in Perth, Australia. So it's an Australian product, but there are some satellite offices. I think there's one in Barcelona as well. So Moodle is a legacy system. First developed in 1997. It went open in 2001. It's 20 years old. It's generally aged pretty well, but it does have an interesting mix of legacy code and new code. All new stuff kind of has very high standards. There's automated code checking, style checking, unit tests, reviews from peers, reviews from headquarters, which I'll touch on a little bit later on, but it's quite stringent to get new code in there. But the older stuff can be a little hit or miss, and sometimes they're sandwiched right together in the same class, which is an interesting mix of code to work on. So, as it's aged, security ages as well, and it varies a little bit in strength and sanity. Some really good things that it does, well to standard. Password hash storage is done through PHP, which has a sane algorithm behind it that is strong and secure. And its access controls are really quite powerful, checked everywhere, and quite granular. So that stuff's done really well, but some things not so much. So the password policy, it's not great. It has a lot of anti-patterns that I'll discuss in just a second. And the authentication flow also suffers from a bit of a lack of customizability and layering, which I'll explain in a little bit. So the first thing we did look at when we needed to actually increase the security of this product, as a vendor, we need to make sure what we're giving people is secure. And the password policy wasn't fantastic. You can see here, this is a screenshot that I took from the master code this morning. It's very antiquated, the old, you must have at least one lowercase, uppercase, and a special character. It's really not what you aim for. So we had to think, if we're going to fix this, what standards should we actually aim for? Now, this is really applicable to anything. If it's not at this level, and it's an open source application, you guys can fix it, and that's kind of what this talk is about. While it's centered around Moodle, it's applicable anywhere. If you've got an app or a service that you like to use and you're not security aware, but you know that these things aren't being done, well, you could fix them. But some standards to aim for. The most sane password standards generally come from NIST, which is the National Institute of Standards and Technologies, I believe, in the US. In 2018, they released a pretty comprehensive guide on a bunch of security things, but one of them that they really targeted was passwords. And they really aim to make passwords more accessible for your average user. Instead of being hard to remember, complicated with character substitutions, they focus on changing the paradigm so that it's instead more centered around things that are rememberable. this is a great example of a terrible password. Most of you are probably familiar with the XKCD correct horse battery staple, which is kind of what you want to aim for in a password, but this is an example of what not to aim for. You can see here there's character substitution, it's prone to sequencing, and it's prone to repetition. So sequencing is when a user might be forced to change their password and they change it from flower123 to flower234. You want to avoid that behavior and avoid enabling that behavior because it means people will do it. If they don't have to remember a new thing when they are forced to change their password, they'll do the least amount possible when changing it to keep it in their heads. So you want to move away from that. So the most important things NIST generally recommends are, as I mentioned, don't force a pattern, don't allow things like sequencing, generally don't allow things like number sequences or anything like that as well. And you want to check for things like dictionary-based passwords and identifying passwords. So the dictionary-based one is relatively important because a lot of people will they'll make their password flower123. And if they've got a compromised password somewhere else that's flower, an attacker now has a really good place to start a dictionary attack. So you really want to kind of, as much as you can, stop people from using a single dictionary word because just having 2 words even really ramps up the complexity and makes a dictionary attack a lot less effective. Another thing to check for is identifying passwords. You really don't want someone to have their information inside their password. People generally will tend to have your kids' birthdays, their own name, city. There's a lot of compromised stuff. I went on a binge of seeing what I could find inside the HaveIBeenPwned password API with my own details, and there was a ton of compromised passwords based on that kind of stuff, like my name. So people are doing this. So you really don't want to allow that, and that kind of leads into the third and most important point. You need to check for compromised passwords. Every service should realistically be doing this that takes a password. All it takes is one data dump, an email, and a password, and now your service is vulnerable to a malicious user. So, talking about the HaveIBeenPwned API. If you're not familiar with it, it is fantastic. It's free, it's easy, and really going back to this can be applied to anything. If you've got an app or a service that you use, you maintain, you've developed, maybe you're not a security aficionado, as I said, but you are a developer, you can put this in. You can check for compromised passwords, and you absolutely should. It's really, really easy. You've got their password, you're deciding whether to allow it, SHA-1 hash, you send the first 5 characters to the API, you get the hashes back, and you just check for a match. It's that easy. You don't have to transmit any actual identifying data. A partial hash is nothing. It's garbage. So it's very, very secure. It's very safe. And it's that easy. This is an implementation I wrote yesterday in Python. It might be terrible. I don't write Python that much. But it's 10 lines. It really is that easy to actually just check whether a password is compromised. And that really is the biggest security flaw in many cases because people do reuse passwords. So just to talk a little more about the dictionary checks as well, passwords based on a single dictionary word are weak. Stringing them together makes them much more secure by leaps and bounds just due to dictionary attacks. But you don't have to target a huge dictionary for what you're actually checking against. It doesn't have to be an exhaustive list. The top 10,000 English words by frequency, they cover 97% of used words. And in general, that's probably what people are thinking about when they're creating a password. They're not thinking of the most esoteric word they can come up with. Maybe it's based off something they see or know or are listening to on the radio. So it doesn't have to be an exhaustive list. And it's really easy to find big dictionaries online. There's plenty on GitHub. A lot of them are based off the Google Trillion Word project that they did a while back, and they released the data for that. Some people have curated that, removed swear words and stuff like that. So it's easy to find a list to check against, and it's an easy way to actually make sure that dictionary attacks, you're not a platform that's vulnerable to it. So identifying information as well, just to touch a little more on it. Things like birthdays, names, cities are all things to look out for. Now, you might not have a whole lot of user data. You might have very little. It might be an anonymous service even, in which case you don't have to care. But if you do store anything, you should check for what you have, because people do use that. I've seen people use the service name as the basis of the password. There's people who use their own name, people who use their kids' names and stuff like that. So you really just check what you have, because you're not going to have all the information. And if it's the kid's name, kid's birthday, you're probably not going to have that. But if you do, just check for it. It's, again, very easy to just string match it. So you can apply this anywhere. It really is that simple. And as I said, if you've got an app that you use, you can do this. In many cases, it's as easy as just opening a pull request on GitHub. It might go through, it might not. But this can be applied to larger services as well. Now, Moodle, big, has a HQ, enterprise level kind of stuff. We work on that, and we work with Moodle HQ. But I'll run you through the process of how it actually happens, so you can still submit patches yourself to these bigger applications if they're not doing it. And I'm sure that there's plenty out there. Going back to the passwords for a second, essentially, with all those checks, we built something that does all this. It's an open source plugin for Moodle, and just we released it for free on our GitHub, as we do with pretty much all of our Moodle extensions. And that had a lot of additional functionality that I didn't really discuss in this little section on it. I wanted to focus on the most important bits, but things like number sequence avoiding don't allow 1, 2, 3, 4 in your password. Check for sequential digits, iterating things, repeated characters. You can have a look at the code if you want to see all of the checks we actually did. There are some stuff based off Australian Centre for Cybersecurity recommendations as well that are a little stronger in a couple of areas. But now looking at authentication flow, and this will tie back to how you can actually, submit code against larger enterprise-level applications. The authentication flow for Moodle, after we had fixed the passwords, had a core issue in that we couldn't really get the security model that we wanted with what was available inside of Moodle. We couldn't stack things together or overlay functionality on an existing authentication flow. The primary aim of this was multi-factor authentication. So Moodle as a platform already has a huge range of authentication methods that it does support. There was a lot of support in core for many common SSOs like LDAP, when just natively supported. And there's a huge third-party ecosystem that adds support for a bunch of other providers like SAML. But the problem was, in the case of something like a compromised password, we didn't really have a defense mechanism against that. We needed another layer of protection in place, because if we've got a compromised password, compromised user, who knows what kind of nasty behavior they can get up to. And all of this is still prone to compromised passwords. They can still go to their LDAP server, sign in, and if there's not protection in place there, then they're in. So the existing solutions that already were around, there was things like MFA, 2FA available. But the problem is all of these things rely on a single authentication flow. It sat on top of a regular password protected account. And so if you needed things like an SSO provider, that's the only way you want people to be able to access your system, then these things just weren't usable. And so we had to have a think and decide whether we wanted to target specifically adding this functionality to the flows that we already supported. SAML is a big one for us. Whether we wanted to address SAML in particular or take a higher level approach on how we wanted to tackle this problem. And so we looked at putting MFA on top of everything else that already exists, augmenting the authentication flow and allowing stacking of different things on top of it rather than modifying just a single flow itself. So a little bit of technical details on how we achieved that. We built an interface layer in between users attempting to do any account actions. So that will stop things like password resets and that kind of thing. You can have MFA there. You can not have it if you'd like. But any place where a user was able to perform an account action, we added hooks where you can just inject your own elements and they must pass for the entire page to pass. We also added some hooks at the start and end of the entire authentication flow so that users will be caught at essentially a hard breakpoint and not able to progress until they've authenticated with MFA or whatever you wanted to have there. But we added some hard breakpoints in that flow where you can inject any functionality you need. And so that allowed us to get a proper MFA solution off of the ground rather than having checks afterwards beforehand that might already allow a user access to the system. We could instead focus on we've got a clean place to control them. And so that patch, changing all of that, was a big change, and moving it into Moodle core is relatively slow. Because once you've logged a Jira ticket for this, you do the actual code patch, you create your pull request, and then there's automated code checks to match the code standards, then there's a peer review, and then an integration review where someone from Moodle HQ actually goes through and has a look and says, yep, this actually is pretty good, and then they test it, and then it's in master. It can take months, but you can still do it. It's absolutely doable because the actual effort most people have to go to is very little. It's still just a pull request at heart. There's more checks on top of that, a little bit more red tape. But if you've got a large application that doesn't do this, it doesn't take that much to fix it from your end a lot of the time. So that's what we did. We worked with Moodle HQ, and we decided on an implementation that everyone could support and get behind that didn't break any already existing authentication flows. And we got it out. So after a few months of discussion and review, the code changes went to master. Yay. So now I had to actually look at MFA, and I just wanted to talk a little bit about the approach we took and some design considerations that are more widely applicable if you need to do this to your solution, your service, or your app. So MFA itself is a superset of the more common 2FA. So 2FA is your standard password plus maybe a TOTP, a temporary one-time password, or it might be an email verification code or something like that. The M is for multi. The idea is you can have more of these things depending on how secure you need your system to be. So you can have, TOTP, email, you could have the password, as well as is it sunny outside. You can really stack it all together as much as you need to match the security of the rest of your system. So we had to think about an extensible platform for MFA. So we decided on a mix of traditional factors and also some non-traditional that really had some benefit and that might be more widely applicable. So your traditional stuff is like TOTP, there's email verification, that kind of stuff. It's the stuff you'd be used to. But more interestingly, you can also think of other things as factors that a user might not even have to interact with. So things like IP verification. If someone is on a secure network that's known good, you can assume they might be VPN'd in or they might be at the office. And if you've got security steps on both of those, it might be reasonable to assume that one of your admins is in a safe, secure environment and that it's them. Authentication type is another one to think about. If someone is SSOing into your service and you know that on the other side of your LDAP login there's already 2FA, you probably don't need it. So it's interesting to think of cases where those will count as factors and the end user has an invisible experience essentially, but anyone outside of that is still forced back to more traditional routes. So when we designed this, we had a couple of clear design goals in mind. They're the pretty standard ones. You don't really want to impact your users. You want to keep it to a minimum while still keeping the system secure. And that's a very delicate balance to walk, but users will avoid as much security as they can. They'll dismiss whatever they can find and get rid of anything. So we had to think about the different use cases as well there, and this is again more widely applicable if you need to do this to your service or app or are just interested. You've got users who might not be required. If your system is not that secure, it doesn't deal with secure data, it might not be required, but you might still want your administrators, say, to have to MFA in which case you might want an optional setup where a user can go activate TOTP if they care about their account security and really need it to be secure. But anyone else who doesn't really, it's invisible. Or maybe it's forced on and everyone is forced to it after accessing for a week of grace mode or whatever you want to have. So there's different use cases there on top of the different factors to use. Some people need to interact with it, some people might not. So you have to kind of think of the way that it's all built in the context of how the rest of your application security is put together and how much or how little you want to annoy your users. So the things we learned at the core are almost anything can be used as a factor. And if you've got things that you know are secure, that interact with the system, you can probably say, yeah, okay, that might actually count as some weight. It might not have to be the only thing, but it might be something or another check that you want someone to meet before they can get into your system. There is a very delicate balance between secure and usable. And this does, again, depend on kind of the rest of the system and what your other security systems are like, how you want users to interact with it, whether you want it to be a streamlined, seamless app. You know, someone's mobile app is not going to be as involved generally as someone's desktop experience in the way they interact with it. You want your mobile to be smooth and streamlined, whereas your desktop might need to be a little more secure. So when designing, being paranoid is probably the right mindset to have. You know, if you've got an input, you want to watch for brute force, especially for things like TOTP and email verification codes. It might be a couple 100,000 attempts, but it might still be doable. So you might want to look, at time delays, lockouts, that kind of thing for that. You want to give the least information possible to allow a legitimate user to authenticate. That's actually really important. If an attacker is coming in, they know maybe an email address, you don't want to leak any more information in their attempted login than they had before, because that's still a win on the attacker's side. So you need to think about what a legitimate user needs to know versus what an attacker might actually gain from the information you're giving them. And you've got to think as well about what can an attacker do if this factor is compromised. Email is the big one there. If email was your only factor, if text message was your only factor, you've got to think about, okay, does that allow an attacker to get into the system? No. If they've got a password, yes. Maybe that's not what you want, because they are things that happen all the time. And again, it depends on the security of your system. But think about the ramifications if these things are compromised. So some final thoughts about this. There's still a long way to go. There is in the security of any application, really. You've got to keep vigilant. Security has constantly shifting goalposts. You need to keep on top of new developments, new attacks, new vulnerabilities, while keeping an eye on the things that have historically been a pain point, and keep it all moving forwards as a kind of whole security model. So don't neglect, I guess, either side of what's traditionally thought of in security. So I just want to say thanks to the Security Miniconf for having me. Thanks to LCA for hosting the great event. Thanks to Catalyst for actually sending me here, taking a week off. It's great. And thanks to everyone for listening. Any questions?
Does anyone have questions?
So you said towards the end there you want to try not to give away information when somebody's doing a brute force attack.
Yeah.
If I put the wrong password in, and the system says no, you can't, that's wrong, then I've given away the information that the password was wrong. Is there any way around that?
I mean, you could just have a blank page, 30-second timeout maybe. It's terrible UX. You shouldn't do that. No. Well, that's a more traditional way to do it. But it depends on whether you've got an email address already. It depends on what the attacker has. But yeah, saying something like that is exactly the kind of thing I'm talking about, minimizing the information you give away, not saying the password is wrong. It's some of your details are wrong. Yeah.
One interesting approach to that I've seen is that if you have an account that has two-factor authentication, it will, regardless of whether the password is correct, allow you to enter a two-factor authentication code. So obviously, that'll only work if the password and the code are correct, but by doing that, you avoid leaking whether the password is correct or incorrect.
Yeah, that's actually a pretty decent approach, but at some point, they're still going to realize that, I'm not fully in the account. Think about your flow, because it really depends on where your users are coming from. If they're coming in from an SSO system or something like that, it's not as important, but that is an interesting approach to it. Anything else?
Any more questions? You mentioned earlier that being able to put MFA on top of SSO services like SAML in particular was something you were trying to solve.
Yes.
I was just wondering if you could elaborate on that. Are you seeing SAML providers just not offering MFA, or?
That's an issue more on the side of the product we were working on. So many of our clients, that kind of thing, use identity providers. SAML is a big one. And they may or may not have MFA on their side. That's really up to them. But for some design goals, we really needed it on the side of we don't trust the person coming in from the IDP. So the problem was we didn't have the ability to monitor who's coming in from the IDP and whether that's actually a valid login or not, or whether it's an attacker, that kind of thing. So we needed to have it on both ends, regardless of whether it existed on the other end.
Okay, that's interesting. Thanks.
One more question?
Yep.
No? Okay. Thank you, Pete. One more.
So with your new password requirements,
Yes.
How do you communicate that to users? Like what's going to be an allowed password?
A pretty hefty, this is our requirements text. Again, it's hard to balance the UX and the cleanliness of your application versus the requirements you actually have to have. Originally, we didn't actually have it quite as verbose, but people were getting tripped up on it, so we really had to make it quite beefy. If you don't have quite as stringent requirements, and it's more just your password can't be compromised and maybe don't use your information, it's a little easier. But if you've got really stringent requirements, I think the best thing is just to put an upfront, we require this for your password, because then people aren't going to get tripped up or not know what they're doing wrong.
Cool. Thanks again, Peter. That was a great talk. And next we have some afternoon tea at 3:10, and we'll be back here at 3:45.